Hey, everybody. This is Chris McTaggart, your presenter for today's presentation on the Build Smart Energy Efficiency Essentials for Modern Homes series. We're going to give it just a couple more minutes to allow our audience to roll in. So just give it a slight minute for us to take that time for people to show up. Okay, I think we've allowed people to start rolling in here. So I am going to go ahead and get started. We have some very nice attendees. Appreciate y'all showing up, and hopefully get a few more people who start rolling in as well. But to get the webinar started for the day, because we have a lot to cover, again, I'm Chris McTaggart. I will be your presenter for today in the Build Smart Energy Efficiency Essentials for Modern Homes series, sponsored by DTE and Consumers Energy. Today's presentation is on the building envelope. And you may say, well, wait, we talked about that last week. We did, but that was about insulation. And so today is talking about building envelope from an air sealing and air barriers standpoint. So if you recall having attended last week's session, or if you're watching these in pre-recorded format, go back and watch the insulation one, because really you can't have insulation that works well without effective air sealing and air barriers. So they really are the combo that is necessary in order to have resilient, comfortable, energy efficient homes. So we're going to be talking about that second part today. So again, we're going to just, for those who maybe were not present last week, we're going to talk a little bit about what is the building envelope. Is that some type of device that carries letters from building to building? No, it's not. We're going to talk about exactly what it is and what it isn't, and why air barriers are critical to having a complete building envelope. From there, we're going to talk about where do we stand in the state of Michigan today with air barriers and air sealing in the energy code. And then we're trying to educate you all throughout this series on above code programs, the existing above code programs that are available today. Today is June. In 2025, we're in the month of June 2025. There are above code programs. We'll see what happens next month, but for right now, they exist. We're going to talk about Energy Star, DOE Zero Energy Ready Homes, as well as applications to Passive House. And then we'll talk about what comes next, meaning next week's series. So again, Chris McTaggart, Building Efficiency Resources. I am the co-founder and president of BER. We are a national resident quality assurance and training provider. We work with about 500 certified professionals all around the country. And we have several raters in the state of Michigan. I myself am based in Detroit, Michigan. This is my hometown. I was born in Detroit and grew up in Metro Detroit for my adolescence, went to Michigan State, and then moved back to the state after a stint living elsewhere, because I just love my home state of Michigan and I wouldn't want to live anywhere else. I'm a big believer in Michigan, our natural environment, our dynamic industries, agriculture, our forests, our fields, our lakes. I love everything about Michigan. I really, really do. I'm a big fan of the west side of Michigan, where we have some raters, the capital region in Lansing, where I went to school. And again, we have some clients in that area. And then even getting into northern Michigan, Traverse City and Petoskey, Charlevoix, Alpena, and even going up into the Upper Peninsula. Whether it be on the east side of the Upper Peninsula with Tequamanon Falls and Pictured Rocks and Sault Ste. Marie and the Sioux Locks, Drummond Island, all the way to the west side of the state, where we've got the Porcupine Mountains and the Keweenaw Peninsula, Marquette, Houghton, Hancock, all those great places. I am a big fan of Michigan, been pretty much all throughout the state. And so that's why you got me talking about where things are coming from here in the state of Michigan with modern homes that promote energy efficiency. That both DTE and Consumers Energy are active in promoting for the benefit of consumers who are purchasing new homes in the state so that they can have comfortable, energy efficient homes that allow them to maintain their quality of life well into the future. So jumping right in, building envelope. We talked about it last week. The building envelope is basically the system of primary air barrier and insulation layer in contact with one another that wrap around the entire six-sided box of our home. Where we heat and cool our home to keep people comfortable. It's a hot, humid day here in Detroit, and I've got my air conditioning on. So I've got my windows closed and latched so that they are nice and airtight. I actually just bought Energy Star windows, brand new Energy Star windows, and they're nice and enclosed and latched, completing my air barrier system of sealed walls, sealed rim joist down to my basement. My foundation walls are nice and sealed. My slab is sealed, and my attic plane is also sealed. So I've got a pretty complete airtight six-sided box. Getting better all the time. This is a 1927 home, and I've done a lot in order to air seal it and to have a complete air barrier and insulation layer, which defines my building envelope. You could also refer to the building envelope as the building shell, the building enclosure, the pressure boundary, the thermal boundary, thermal enclosure. They all kind of mean the same thing, basically. Going into, why the building envelope matters, again, it defines our conditioned space, our heated and cooled boundary of our home. If I had my air conditioning on and my windows were open, well, all of a sudden I would be air conditioning not just my, the volume of my home, but also the air that's coming in from outside. That would be pretty wasteful because there's hot, humid air that is outside. And if I was to just wantingly let it inside of my house, I would have to all of a sudden pay in order to wring out the moisture and temper that air to be more comfortable inside my home. Well, that doesn't make a lot of sense. Yeah, exactly. That's why we need a sealed building envelope. It needs to have a complete air barrier system, and it needs to be air sealed with insulation in order to complete the building envelope, because it doesn't make sense to condition outside air. We want to keep the occupants comfortable. We don't need to spend money in order to condition outside air. And the same thing works in the heating season. If we allow our house to leak because it does not have a complete air barrier or a sealed air barrier, well, then we're having to pay to condition that outside air. That doesn't make any sense. It makes a lot more sense to have a sealed home with a complete air barrier system to define conditioned space, and then we can temper that and keep that comfortable. You may say, well, yeah, but houses need to breathe. That's not true. Occupants need to breathe inside the home, and moisture needs to be diluted inside the home. We can do that with mechanical ventilation. Not the purpose of today's presentation, but we will be getting into that in subsequent iterations of this series. So what is included in conditioned space? Pretty much always bedrooms, kitchens, bathrooms, living rooms. Primary living spaces are our conditioned space. Sometimes we have things like attics that are part of conditioned space. Take my home. It is a 2.5-story home. So that third story that has partial finished living space also has unfinished attic space. Well, some of those little knee wall spaces, I chose to insulate at the roof line, therefore bringing those little cubby spaces into conditioned space. And the benefit of that is now I have tempered storage that I can use. And I do have a small amount of ductwork that runs through that space. And so now, instead of it being an vented attic, where any losses from the ducts are just being wasted into the attic space, now any losses from that ducts, they're not really losses because they're coming into conditioned space. They are part of my house. Same thing for my basement. My basement is part of conditioned space. I have insulated basement walls. I have a sealed rim joist, and my ductwork is present there, and I'm directly conditioning that basement. We don't always directly condition our basements in Michigan, but almost always they are part of conditioned space or the building envelope in the state of Michigan, and increasingly crawl spaces are as well. There's a lot of benefits to sealing and encapsulating crawl spaces, as well as directly conditioning them, because it can help to manage moisture that comes from the ground, potentially mitigate issues of soil gases that could potentially come in through the ground, and in general, just make those much more comfortable underfoot for your living space. So crawl spaces, increasingly, I would say in Michigan, are becoming sealed and conditioned crawl spaces. Not a requirement, you can vent them, but vented crawl spaces, they're tough to insulate well, they're tough to air seal well, and then your house is pretty connected to potentially a dusty, musty old vented crawl space, and that's just not nearly as nice as a sealed, conditioned crawl space. Sometimes, but rarely, garages are part of conditioned space. For HERS ratings and Energy Star and programs like that, garages are pretty much never considered part of conditioned space. Occasionally, for energy code purposes, a code official may define a garage as being part of conditioned space if it has intentional conditioning. Same thing for porches. Sometimes you may have a 4-season porch, but more typically, you'll probably have a 3-season porch where it's not being directly conditioned. Okay, so again, what defines the building envelope? You have to have an airtight layer that's contiguous and in contact with then your insulation layer, and that completes your building envelope. You can't just have an air barrier and then move the insulation away from it and have it suspended in space and expect that the insulation is going to perform well. It's not necessarily going to work that well if you do it that way. You need to have that insulation in contact with the surface that's intending to insulate. And then we need an airtight air barrier system that's sealed so as to prevent basically wind washing through that insulation, which diminishes its effectiveness. Oftentimes, then we also have weather resistive barriers that are part of our building assembly. So things like Tyvek. But don't get confused. Tyvek generally is not our air barrier. Usually when we're talking about air barriers in residential construction, we're really thinking about it 2 different ways. You could either have your exterior sheathing, so plywood or OSB, or occasionally maybe even some type of Den's glass, some type of gypsum board sheathing. Ideally, you would seal all the seams and penetrations through that OSB or plywood, potentially with a proprietary system like the zip system, or maybe with some type of liquid applied, trowelable air sealing product. And then that way your exterior air barrier is nice and tight. The benefit of that is then the air, the wind, when we have a windy day, it's not pushing, untempered air into our wall assembly. Why don't we want that? Well, it can potentially lead to condensation, as well as a reduction of performance of the insulation product itself. So that would be a great way to do it. I'll say, especially when you get into things like high performance homes, homes that are meeting zero energy ready homes or passive house. Pretty much everybody, once you get to that level, is doing some type of air sealed exterior sheathing in order to achieve the air tightness provisions that are required by those programs. You can do airtight interior drywall or airtight drywall method. Basically, that's saying, well, we're going to allow the sheathing to leak, but then we're going to make sure that our drywall is nice and sealed. So that'd be things like having putty packs on the back of outlets or electrical boxes, sealing with caulk or tape around some of those drywall penetrations. Those are all possible. I will say it's a very tedious thing, and it's easy to get it wrong. And it's not necessarily going to save you any money. I think that builders and raters tend to think that airtight drywall is sort of like, well, it's the way we've always done it, so it must be less expensive. But to do it really well, to the level where you're going to have repeatability in achieving very strong airtightness goals for a home, it can be very expensive to implement to get it right. So we're going to talk about both methods, airtight drywall as well as airtight sheathing. But I am here to tell you that if we're talking about modern homes for modern energy efficient construction, I think it's time for most builders and raters to start to take a good hard look at sealing our sheathing, because that's really where we want to stop air and moisture from getting into our homes to begin with. Okay, air barrier basics. Why do we insulate homes? Well, I thought we were talking about air barriers. Remember, you cannot have one without the other. And air barriers have the same reasons why we insulate homes. So if you remember last week, we said, why do we insulate homes? And we said for energy savings and comfort. And it's the exact same reason why we have air barriers, plus durability. Having an air sealed building enclosure ensures that that home will be more durable from the risk of condensation that may occur within building cavities. So how do we think about this? One way to think about it is like, all right, everybody in Michigan just about likes to get out to the great outdoors. We love our 4 seasons. We love to go out in fall and go apple picking and drinking apple cider, hay rides, and all that good stuff. Nice nature hike, crisp day outside. Well, but if we're going to go outside on a crisp day, we probably want to have an insulation layer, right? We want to have a sweater or perhaps some type of fleece, some type of insulated jacket. Okay, without a doubt. And especially if we're going to go out in winter time, if we're going to go outside when it's snowing and 20 degrees outside or less, boy, we definitely want to make sure we have an insulation layer on our bodies. Why? Because our bodies are 100 degrees, it's 20 degrees outside. If we had no insulation on our bodies, we would be wasting a lot of heat off of our bodies. And that would be not only uncomfortable, but it would also make our bodies have to work a lot harder because we would have to produce a lot more energy to keep us warm, basically. So got to put on that insulation layer if you're going to be outside when it's cold. But what happens if we got this nice wool sweater? Nice wool sweater, a little bit itchy, but it certainly is warm. Well, what's the problem with the wool sweater? Well, when the wind blows, it blows through all those little pockets in our insulation layer on our bodies, and now we're wasting heat. I'm no longer comfortable anymore. Darn it, how do I resolve that? Well, you have to put a jacket on. You have to put something that has a sealed air barrier on it. So we put on one of those nice puffy coats on top of our insulation layer, and you'll notice it's sealed. It's not just fleece, generally speaking. It has some type of airtight layer on it, be it some type of plasticized poly, woven poly type of fabric, or something else, a nice sort of solid woven cotton type of thing. But regardless, we want it to be airtight, so that way when we're out, skiing or we're doing something fun outside, and the wind is blowing, that we're not just having all of our heat blown off of our bodies, because insulation alone isn't good enough to keep people comfortable. We need to have an air barrier over that insulation. You have to have that jacket over that sweater in order to keep people completely comfortable. So it's the same thing in houses. You got to have an air barrier system on top of your insulation layer to complete the building thermal envelope. So, an air barrier system ideally is a solid sheet good. Think about OSB or plywood. Can we seal that really well? Or at the very least, our drywall, Let's make sure that that's nice and sealed so that we prevent air leakage or basically, the elements from coming inside of our home and making us less comfortable and costing us a lot more money to heat and cool our homes. It needs to be sealed at all the joints and seams and transitions, not just some. Again, I would argue that where we've got plywood or OSB seams, why aren't we sealing them? I mean, I will go into homes that pre-drywall and I'll look right through and I'll see daylight to the outside from our OSB. Guess what? Air is coming in, so is moisture coming in through all those seams. It'd be a lot better to seal it at that point. And then if it comes to the inside with drywall, that's fine. But then you've got to picture frame all the drywall, top and bottom and sides, and where it transitions to windows and doors and outlets. It's a lot more work to get well. And there's a question is it very durable? Meaning, does that air seal last? So, has anybody ever gone into a home at pre-drywall and they see that somebody has sealed, say, a gang of wires, but then later on come back and have found that there's air leakage from that same spot? Well, that's because the electrician comes to that gang of wires and yanks on them in order to make their connection, and it maybe breaks that seal, whether it's spray foam or caulk. They're not doing it to be destructive. They're just doing it because it's sort of unintentional and they're not thinking about air sealing. But that's one of the issues when we try to take it on the inside of the walls and seal that way, is that it's potentially not very durable. So ideally, our air barrier system is not just continuous, but it's also durable. Again, insulation, our sweater, it reduces conductive heat transfer, basically heat that isn't, basically on our bodies, conducting into that insulation so that it doesn't conduct out into the outside conditions. Air barriers reduce convective loss, which is through basically air movement. So the challenge with air leakage, and again, people say, well, houses need to breathe. We want homes to leak. Well, guess what? When we have Canadian forest fires and my child has asthma, do I want my house to leak so that I can bring in all that nice, smoky, fresh air? Absolutely not. Absolutely do I not want that. And with a mechanical ventilation system paired with an airtight house, you can temporarily turn off that ventilation system, or you can have it where it's filtered air coming into the home. If you have a leaky home, so the air is just coming in and out without any ability to control it, then unfortunately that child is being exposed to smoke. And therefore it's potentially really bad for their health. And so, and then we got issues of moisture. Right now it's humid. If I have, and I'm air conditioning my house, if I allow humid air into my wall assemblies, and I'm potentially really cooling my house to the point where maybe the drywall is like at a dew point temperature, that could potentially lead to condensation and moisture and maybe mold or decay issues inside of building assemblies. And so we don't want really cold or really hot or really moist air coming into our wall assemblies or our ceiling assemblies or our floor assemblies, because that can lead to potential moisture issues and therefore potentially some mold and health issues associated with that. The other issue with having air leakage is it provides an opening for pests to get inside. I actually have a rental house that I rent out to some people, a duplex here in Detroit. And one of my tenants just texted me yesterday complaining that there were ants allowed to get in underneath the exterior door. And so they wanted me to reseal, re-weather strip the door. Why? Well, because not only was air getting in, but also now pests had a way to get into the home. If we have a nice contiguous air sealed home, pests can't as easily find a way into the home. And the final thing is that it's an energy thing. Not only increased heating and cooling, we've heard about drafts, draftiness. Well, draftiness is caused by basically air leaking out of the home and being made up by cold incoming air. And we'll talk about that. There's there's an effect called stack effect that deals with why we feel drafts, and it leads to increased heating and cooling in our homes. But the other thing that isn't appreciated is insulation. Again, if you attended last week, the way that insulation works is that it's actually trapped little pockets of air, especially within fibrous insulation. So then if we've got wind rushing through because we got a 20-mile-an-hour wind bearing down on our house and it's 20 degrees outside and we have unsealed gaps of our sheathing, well, guess what? It's blowing that wind inside of the insulation and therefore reducing the ability for those pockets of air to trap that heat and therefore provide sufficient insulation. It's called wind washing. It can also lead to what's called convective looping, where basically you've got a similar thing typically going on more vertically within the cavity. Regardless, it reduces the effectiveness of the insulation, therefore, again, increasing our energy use and also potentially leading to possible durability-related issues. So it's an underappreciated part of our industry. But just think again, I think we've all been outside in wintertime with a fleece on, and then a wind really kicks up, and all of a sudden that fleece don't feel so well anymore. And that's because fleeces generally do not have a complete airtight air barrier. They're somewhat permeable. Even worse would be a wool sweater. Wool sweater, man, they're nice and comfy in still air, but if you have a big strong wind, it's not going to be quite as comfy anymore. Okay, we've got a poll question, and we're going to go ahead and throw that up right now. Where do you think most uncontrolled air leakage occurs in a typical home? And we're going to give people a couple of minutes to answer. We got one person who answered. We got 7 total people here. Let's go ahead, and there we go. We got some people rocking and rolling on it. 10 more seconds. We're going to cut it off here at 30 seconds. Here we go. And the poll, where do you think most uncontrolled air leakage occurs in a typical home? We're going to share the results. So the majority of participants said at the top and bottom of the house, and that is absolutely correct. If we have unsealed gaps in our attic plane, that allows for warm air to rise and escape through those penetrations in our attic plane. And then, the home contains the same volume of air no matter what. So if you have warm air escaping, that means that we have positive pressure at the top of the home and therefore negative pressure at the bottom of the home. Think about like your rim joists that connect to your foundation. Oftentimes that's a passageway for air to leak into the home. And so we've got cold outdoor air coming in through those penetrations at the bottom of the home, which is why we feel drafts as being so uncomfortable, because warm air is escaping and cold air is rushing into the home. Certainly, if your windows are not installed effectively, you can have air leakage around windows and doors. I made sure when I got these brand new windows installed that they were spray foaming around the perimeter of the rough opening so that I don't have leakage around my windows and doors. Okay, so again, stack effect, that's what we were just referring to. Where we have a temperature difference or possibly a wind effect, that causes there to be what's called a stack effect, where you've got increased pressure at the top of the home and negative pressure at the bottom of the home. So why does this happen? Well, most of the time here in Michigan, as we all know, especially this year, we've got darn near 6 months of heating, maybe even almost 8 months of heating this year. And so we're heating up air in our homes to say 70 degrees. That warm air is rising because of buoyancy of the air molecules. Warm air is less dense, and so it rises, and cold air falls to the bottom. So that warm air rises up because it's less dense, and it builds up a higher pressure at the top of the home, and so it's going to seek to try to escape. And so if there are gaps within our ceiling plane, such as unsealed wire penetrations, unsealed electrical penetrations like bath fans or can lights, possibly plumbing stacks that are unsealed, ductwork that's in the attic that's not sealed, etc. That's a path for air to escape, and therefore we are losing conditioned heated air to the attic in this diagram. Well, again, the house has a certain cubic volume of air no matter what. It's not like we're going to suck all the air out of the house. So we have to bring in more air from outside, and it's typically coming from the bottom of the home, and that's going to be cold, untempered air. And so essentially, the stack effect is what causes draftiness in a home. And so the more unsealed the home, the greater the rate of this stack effect, and therefore greater the feeling of discomfort from draftiness, as well as more air is lost and therefore has to be paid to be retempered. Similar kind of thing, wind washing. This can happen in a couple different spots. It can happen in unsealed wall cavities, but it oftentimes happens in attics if we don't have proper baffling at soffits of vented attic spaces. That can cause basically the wind to blow in through the soffits and therefore wash through the insulation and reduce its effectiveness, or even just blow it out of the way entirely to the point where there is no insulation above those top plates. So having proper eave baffles is very important for that reason. Again, there's a risk of convective looping as well if we have any amount of convection inside of walls. So if we have unsealed exterior air barriers and the wind is blowing in, that can cause there to be this looping effect that occurs inside the wall cavities, which reduces the effectiveness of the insulation. And so again, something else why having an air sealed exterior air barrier is worth investing in, because if we're going to install an R20 bat or something like that, we would like it to perform in an R20. If there's convective looping that's occurring inside of that cavity, and maybe it's dropping it down to, an R17, well, we just lost a decent amount of our thermal resistance because of that convective looping. Again, another very underappreciated element about having sealed air barriers is maintaining durability of the home. In fact, when you get to passive house levels of performance, passive house requires a very aggressive air tightness level, and we'll get to exactly what that is. But the main reason is to prevent condensation. It's to prevent the risk of moisture getting into wall assemblies and soaking into insulation, and therefore causing mold and decay and durability related issues. Well, how does this work? Well, moisture can move in buildings a few different ways, through direct contact through a process called capillary action, or it can happen through moisture vapor, called diffusion. And so again, it's humid outside right now. There's probably a very small amount of moisture that's getting through my wall assembly and into my house just through diffusion, because it's dry inside and it's wet outside. But that's a really small amount of moisture that's getting in. However, if I have an unsealed air barrier system, that's allowing tremendously more moisture to come in. So look at this, just 1 square inch hole in a sheet of drywall over the course of an entire heating season could let in 30 quarts of water, just through having unsealed air barrier system. So it's important to seal walls and seal ceilings and seal our floors and other elements of the building enclosure for the purpose of improving the durability of the home, preventing condensation, in addition to making people more comfortable and increasing the thermal performance of the home. Oh, and Patrick McCaffrey says that the illustration has been updated and the numbers are actually even worse than calculated. Thanks, Patrick. I'll have to look for the updated graphic on that. And it probably depends on your climate. Obviously, if you go to the desert Southwest where there's not so much moisture in the air. It's maybe not quite as big of a deal, but especially here in Michigan, we're pretty humid in the summer. And then we have warmer, moist homes in the wintertime. I could definitely see this being an issue in Michigan, without a doubt. Okay, so air barriers. Again, there's two different ways to look at it: an exterior air barrier or an interior air barrier. And so if we're doing exterior air barriers, which I'm encouraging you all to really consider more, because we're talking about modern approaches to energy efficient homes. And I'd say a modern approach is seal your darn sheathing. If you stop air before it can get into your walls, then it's going to make your job a whole lot easier. And yeah, some of those products to execute that can be a little bit of a premium, but a smart, savvy builder will do the math and realize that that premium actually maybe makes it back for himself, because you're not having to spend quite so much money on nip and tuck type of air sealing within the home through the airtight drywall method. Because when you do the airtight drywall method, now you got a lot of additional penetrations that have to be considered if you want truly a really airtight, well-sealed home. So what would be considered to be an exterior air barrier system? Well, here's a couple of examples. The zip system, that's a big one. They're not the only ones, but that is a proprietary product through Huber that, it's a good system. It is comprised of OSB that has a WRB water tightness layer on it, but then it also has an air sealing tape that connects at all the joints and seams, as well as some liquid flashing products to be able to connect into things like foundations. And so that's a really good example of an exterior airtight air barrier system. Another one would be like this Henry Blueskin. This is a peel and stick membrane that goes over standard OSB sheathing, and also, again, does air sealing as well as acts as a WRB. There are also liquid applied products where basically you can either spray or roll on the product, and that creates also, again, an air barrier, as well as some of them also act as a weather resistant barrier as well. And again, the idea here is let's keep the air out before it gets in the house to begin with, and then we don't have to spend quite so much time picture framing our drywall and trying to get that perfect on the inside. The airtight drywall method is more of that picture framing, where we have to seal things like the bottom plates of our walls to where the drywall is applied. And we need to seal the rim joist at both the top and the bottom, and then where it meets the foundation wall. You have to seal all penetrations that go through the attic, like top plates, bath fans, and other plumbing or electrical penetrations. You add that up throughout an entire, let's just say, standard 2,000 square foot house. Boy, that's a lot of stuff that has to be sealed. And I see builders do a lot of things where they're almost like trying to get an airtight exterior, but they're doing it on the inside. And so if you see this top right side, we've got, a spray foamed interior picture framed cavity in order to try to seal up that OSB. That might work, but it's a lot of work. Look at that. I mean, hey, somebody had to spend a lot of time picture framing each and every single one of these cavities. That takes a lot of time. And then there's no guarantee that it's really well sealed at the bottom plate or the top plate either. So I'm not saying don't do this. I'm just saying consider the costs and benefits and the time that is spent doing these types of methods. I see builders going, oh yeah, we air seal. I have somebody go and caulk every seam of every stud throughout the entire house. That's a lot of caulk. And caulk is getting more expensive. It's not necessarily that effective to do that. And so sealing the exterior of the home first has a lot of merits into making sure that, like, we did it once and we did it well. If you bring it to the inside, now you have to do you have to prevent the death by 1,000 cuts. And that gets a lot more challenging. Different types of air barrier products, rigid air barriers. So like sheet goods, drywall, OSB, foam board. You can use flexible air barriers sometimes. So like some markets, maybe this even happens more in like, the UP, I'm not quite sure, but like in Minnesota, they tend to, and in Canada, they tend to use poly sheathing, so visqueen, as an air barrier system. In our climate, it's questionable whether or not that's the best, especially downstate. It's probably better to have more vapor open building assemblies rather than using poly as an air barrier. But in certain markets, this is definitely used. There are smart vapor retarders, such as this Intello product, that both allow some vapor to pass through as well as are airtight. So there's a CertainTeed membrane, as well as Intello, and there's a few other manufacturers that make something similar. And that way you can have airtight interior that you can take care of it really well on the inside, and it does allow some vapor to pass through as well. Okay, we're going to talk about another issue. Can spray foam be used as an air barrier? And if so, what is a potential issue with it? Okay, time for participation, my people. On the presentation, please go ahead and fill out this poll if you are present. Here we go. We got people starting to answer. Can spray foam be used as an air barrier, and what's a potential issue with it? We need a couple more participants. Looking for some poll participants. And we're going to give it another couple seconds here before we go ahead. All right, we got some more trickling in. And we're going to do a nice 5, 4, 3, 2, 1. And we're going to share the results. So most people did share the correct answer, which is that yes, spray foam can be an air barrier, but it depends on its installation. Spray foam is not the end all be all. It can be installed well, it can be installed poorly. It can be installed contiguously, it can be installed in more of a haphazard fashion. So we got to be careful not to assume that spray foam is the end all be all and will always work, but yes, in fact, it can be an air barrier. So spray foam, it really depends on the thickness, and depends on what type of foam. So closed cell foam, basically you can get a complete air barrier with as little as an inch of closed cell foam, but it's got to be contiguous. It's got to be throughout the whole thing, and it has to be applied in the correct curing fashion, so the correct temperature conditions. The substrate has to be the right temperature and moisture conditions, or else that insulation may not cure properly. Got to be careful for pockets or voids or gaps where it's not complete and contiguous. Open cell can also be an air barrier, but it's got to be a little bit thicker in order for that to count as an air barrier. Again, we want contiguous air barriers, not haphazard air barriers. All the gaps and seams and transitions need to be taken care of, and not just like if you're using the zip system, not just the vertical and horizontal seams, but also where it ties into the foundation, to the ceiling, to the walls, to windows and doors. And then any other type of penetrations that go through that air barrier need to be sealed. So like here's the classic example. Here's like a Cape Cod style house, or perhaps like a bonus room over a garage. And so, we've maybe got attic space on one side, and then we got living space on the other side. And guess what? We've got wide open joist bands that run from the unconditioned attic underneath the floor system of the conditioned living space. Well, that's not good, because now we got air that's rushing in underneath that conditioned living space. That's definitely going to cause some comfort and energy loss issues. So we would want to find a way to seal up those joist bands to make sure that we aren't losing air that way. Knee walls. So attic knee walls, they need to be sheathed on the backside. Again, insulation only performs at its rated R value if it's is able to have that trapped still air. If you have that bat exposed to the backside of the attic, well, the attic's not perfectly still air, right? And so you've got, basically a reduction of the performance of the insulation in the attic if you just have it exposed. So we want sheathing on the backside of it. And then you want to cap those knee walls at the top. You don't want to just be wide open to the top of the attic, because that is a place where we're going to have air leakage occur to the attic. When you do the airtight drywall method, you got a lot of different places you have to seal. You have to seal any shafts, like a chimney stack. You've got to seal around windows and doors. You have to seal rim joists. You have to seal penetrations to the attic. There's just a lot more penetrations to the garage. It ends up being a lot to have to deal with. When you're doing exterior air barriers, it's a little bit easier in order to see what you have to seal and do it in a little bit more of a contiguous fashion. It can be done with tape, it can be done with caulk, it could be done with foam. There's a lot of different ways to do it, but you got to make sure that all those penetrations are sealed. If you're, running into the attic, the major things that we got to think about are the biggest openings. So chases, like duct chases or chimney chases, where you got many square inches of opening running from conditioned space up to the attic. That's bad. That's going to cause there to be a durability risk, a energy loss, and a place for the stack effect to be exacerbated. Top plates, where basically the interior walls or the exterior walls meet the attic plane, those tend to be a source of significant air leakage, especially in older homes where basically there's a gap between the drywall or the plaster and that top plate. That can be a major conduit for air leakage. Big fat penetrations like through plumbing stacks, and then electrical wires, etc., are an issue. We have to seal the base plate if we're doing airtight drywall method. You have to seal with foam or with caulk. You can't just leave it unsealed, or else we're going to get air that's rushing in. Why? Because that plywood sheathing is 4x8, and if you got an 8-foot tall wall, well, guess what? It's going to go top to bottom to your top plates and your bottom plates, but it's not going to seal the base. We got to make sure that's sealed. Again, up in the attic, sealing the top plates, very important, especially over time. That drywall tends to pull away, and it leads to major linear gaps that allow air to leak into the attic. It's one of the more pernicious areas of air leakage that occurs. Around windows and doors, again, you got to either foam or caulk or use some type of expanding foam tape or just air sealing tape in order to seal around the rough opening of windows and doors. In the attic, all these different penetrations, can lights and bath fans and duct boots. It's a lot of stuff that can be left unsealed. Honestly, that's why I always like to tell builders, if they're going to use an airtight, drywall method like that, send a laborer up in the attic and just tell them seal daylight. Anywhere that they can see down into the living space and they can see light coming up, that's probably through a gap in the drywall. Just go ahead and seal that with foam or caulk. And you send a guy up there, or a laborer up there with a few cans of spray foam. They're going to do a really good job overall getting that done, and it's not going to take that much time or money. Honestly, it's a missed opportunity even in modern construction today, but it's technically supposed to happen on every home per code. Floor penetrations, this could happen through a cantilevered floor, or if we had a vented crawl space or an unconditioned basement, possibly, you'd want to seal all the penetrations to that floor, like duct boots, plumbing, electrical, etc. Going back to your attic, again, you want to make sure that any attic hatches are sealed. So ideally would have gasketed weather stripping, as well as sealing around that attic hatch. So I'm just going to go ahead and skip this poll because we got to get going on time. But which of the following are benefits of air sealing in multifamily? It's all the above: sound reduction, smell reduction between units, blocks pollutants from entering adjacent in a unit. So imagine somebody smoking in a unit. If you have air tightness in dwelling units, it really helps to prevent that. And then it blocks insects again, possibly from coming in. So multifamily, you cannot just rely on the exterior being well sealed. You have to seal those party walls so that you're completely compartmentalizing the unit, both the walls as well as the adiabatic floors and ceilings need to be sealed. A great way to consider going about this would be through AeroSeal or AeroSeal for homes, aka Aero Barrier. They've done a couple rebrands here recently, but I think they're back to Aero Barrier. Basically, it's a pressurized aerosolized air sealing method. You've probably seen it for ducts before, AeroSeal for ducts, where they can basically fix a flat if you've got leaky ducts. Well, you can do the same thing with a dwelling unit. And it really works very well for multifamily. And there's a lot of builders that are moving to this as a primary method for air sealing in single family as well. All right, so jumping into the code, what does the code require? Well, there's prescriptive requirements for air barriers and air sealing details in Michigan. And we also prescriptively have to test a home to 4 ACH 50. Now, this is if you're following the prescriptive approach. If you're performing the performance method, homes are still supposed to follow this air barrier and air sealing approach. And again, all this table stuff, this is all these best practices we've already been talking about. Sealing attic knee walls, sealing attic hatches, electrical penetrations, rim joists, all that good stuff we've already talked about. What's interesting on the performance or ERI method is technically you can do leakage, but it can actually be greater than 4 ACH 50, so long as you pass that performance method. So that's the current Michigan code, the 2015 Michigan Energy Code with amendments. You can technically be more than 4 ACH 50, but certainly we would not like to shoot for that for our homeowners. Getting into above code programs, start with a HERS rating. HERS doesn't actually require any prescriptive or mandatory air sealing measures at all. There's no hard requirements for air barriers or air sealing, but it's really hard to get a good score without a combination of good air sealing and proper ventilation. And again, a reminder, you can get in the door with your builders for Consumers Energy by achieving a minimum HERS index of a 59, and then for DTE, a 60. Energy Star has specific air barrier and air sealing requirements. They come from the Rater field checklist. And there's a lot of overlap in these requirements with code. So basically, what code requires, more or less Energy Star requires. The only difference is that you have to document the requirements of Energy Star with a checklist, and with the newest revision, you're also supposed to be doing some selective photo documentation of some of these measures as well. For the newest revision of Energy Star, they actually moved forward in Rev 14 with having mandatory air tightness levels. So for version 3.1, we have to be 4.5 ACH 50 or less. So that's a little bit more leaky than prescriptive code, but we can't get a whole lot more leaky than that. So if you're doing the minimum Energy Star version in Michigan, you have to get to that, 4.5 ACH 50. Honestly, that should be pretty hard to not meet in Michigan if you're following the standard air sealing and air barrier requirements that come out of the code as well as come out of the Rater field checklist. If you want to get into doing the 45L tax credit while it exists, version 3.2 and version 3.3 of Energy Star pertain, as well as for the Next Gen program, if you want to participate in the Consumers Energy pilot for Next Gen that runs through the end of 2025. Basically, 4 ACH 50 is what's required for version 3.2, or for version 3.3, permitted after 1/1/27 would be 3.5. We'll see if the Energy Star program finds its way to January 1st, 2027. Remains to be seen. There is an exemption that pertains to all of these programmatic thresholds for attached dwelling units, or those that are less than 1,500 square feet, where you can, instead of using ACH 50 as an air tightness metric, you can use CFM 50 divided by the shell area of the home, and that would be a suitable alternative. And for the frame of reference, that typically comes in somewhere around 5 to 7 ACH 50, depending on the configuration of the dwelling unit. Zero energy ready homes, there's no specific additional air sealing or air barrier requirements. You just have to meet version 3.2 of Energy Star, so that 4 ACH 50 level, which is nice because that is the same as our Michigan threshold for Michigan's energy code, which is 4 ACH 50. So as long as you're meeting that prescriptive Michigan energy code air tightness level, you're good to go for Energy Star version 3.2 and therefore zero energy ready homes. Now, what's interesting though, and this is where I think a lot of people get caught up, when they look at the national program guidelines, they see how the reference home is defined, and they see that in climate zones 5, 6, and 7, which is what comprises Michigan's climate zones, that the reference home has a 2 ACH 50 air leakage limit. Again, this is how that reference home is energy modeled. So let's imagine your home leaked 4 ACH 50, the reference home leaks 2. Well, that just means that you have to have other energy savings methods in your ERI calculation to make up for the fact that your home is a little bit leakier compared to the reference home. But it doesn't mean that you have to meet that 2 ACH 50. And I've seen people make this mistake with Energy Star for a long time, and now with zero energy ready homes. They see this table in the national program guidelines and they think that you have to meet that level. It's not actually true. You just have to beat it from a performance basis when comparing to the reference home. Okay, we've got time for this poll. Let's go ahead and run this poll. Made up a little bit of time. Which of the following has the strictest air tightness requirements? Michigan Energy Code, Energy Star version 3.2, zero energy ready homes version 2, or all of the above have the same leakage rate. Here we go. Last little bit of time to participate. We've got some people answering. I love to see it. Come on, folks. We're almost at the finish line here. A little bit more participation up to the bitter end. We're going to go ahead and roll with this in 3, 2, 1, and poll. One person snuck in at the last minute and got the right answer. So the answer is that all of them have the same leakage rate. It was a trick question. Michigan Energy Code's prescriptive air tightness level is 4 ACH 50. Energy Star version 3.2 is 4 ACH 50. Zero Energy Ready Homes version 2 points to Energy Star version 2 for its requirements and therefore requires 4 ACH 50. And basically, therefore, all of them have the same leakage threshold. So basically, the person who snuck in there at the last minute got the right answer. Okay, so moving on, last but not least, passive house. And again, we're going to have whole lessons that are just devoted to passive house later on in this series. So this is kind of brief, but PHIUS, the Passive House Institute US, based in Chicago, that is one passive house certification standard. And then we have PHI, which is the Passive House International Standard that's based in Germany. They also have satellite certification here in the United States. So PHIUS requires 0.06 CFM50 per shell area, whereas PHI requires 0.6 ACH50. When it comes to a single family home, that means that PHI tends to be a little bit more airtight. That PHIUS level in a single family homes context ends up being close to about like a 1 ACH 50. We're going to show you how this works. So, a high performance home, yeah, that's passive house for sure. So ACH 50 versus this ELR or square foot, CFM 50 per square foot. These are among the most airtight homes you can really get, without a doubt. So here's a comparative difference. Let's just go ahead and take a 2,000 square foot, 2-story home, 9-foot ceiling heights, a perimeter of 40 feet by 25 feet. Well, how does this work out? Well, from an ACH 50 standpoint, we get 18,000 cubic volume times 0.06. That would give us 260 CFM 50 of air leakage that is allowed. If we did that would be 180 CFM of air leakage allowed. If we did CFM per square foot, we've got 4,340 SFBE, square footage of the building enclosure, times 0.06 equals 260 CFM, which if we use the same volume, that would give us 0.87. So sometimes there's battles. Which passive house is better? Oh, the old school German one is a lot more stringent. Well, guess what? It's incrementally more airtight. Big whoop. We're not talking about a big difference here. People are not going to particularly feel that difference of airtightness. FIAS had a scientific basis. I'm sure that PHI did as well. They both result in very airtight homes. I'll tell you what, when you get to bigger buildings, though, like multifamily, the FIAS standard actually tends to get more airtight compared to PHI. Regardless, we are at time, exactly noon. And so the next session next week is going to be on fenestration, all about windows and doors and skylights. And we got a lot to talk about because I've learned a lot about this topic recently, and there's a lot more than meets the eye. Don't miss it. Join us again week from today, same time, same place, and I look forward to seeing you then. Thank you.